Example question 16. A car slows down from a speed of 31.0 meter per second to a speed of 12.0 meter per second over a distance of 380 meter. How long does it take assuming constant acceleration? And what is the value of this acceleration? So let us first write down what is given to us. I have the initial speed of the car, which is V0, equal to 31.0 meter per second. Then we have the final speed V, 12.0 meter per second, and the distance over which the car travels, which is x minus x0, that is equal to 380 meter. I need to find how long it takes to cover this distance, that is the time t, and the acceleration of the car. So we can first solve for part B to find the acceleration, and then go to part A to find how long it takes to cover this distance. We have been given the initial velocity, final velocity, and the displacement x minus x0. So to find acceleration, I will use the fifth equation of motion, which says that v final squared equals v initial squared plus 2a x minus x0. If I want to find a, I need to get rid of all the terms present on the right hand side. So first thing we will do is move v0 square to the other side. So I will write v square. When I move v0 to the other side, it will be subtracted. So negative v0 squared equals 2a x minus x0. Now since 2 and x minus x0 are multiplied to a, in order to solve for a, I need to divide by these two quantities. So I get a equals v square minus v0 square over 2x minus x0. Now we solve for acceleration a. I have v as 12 squared, v0 is 31 squared over 2 times x minus x0 is 380. And when I solve this, I get the value of this constant acceleration as negative 1.075 meter per second squared. Now let's find the time t in part A by using the value of this acceleration. I have the acceleration a, I have the initial velocity, I have the final velocity. So to find the time t, I'm going to use the third equation of motion, which says v final equals v initial plus acceleration into time. If I want to find time, I need to get rid of all the terms on the right hand side and leave the time t alone. So we move v0 to the other side. We get v minus v0 equals a into t. Then we divide by the acceleration a. So we get t equals v minus v0 over a, or the time t equals v is 12, v initial is 31, acceleration is negative 1.075, which we found in part B. And when you solve for this, you get your time t as 17.7 seconds. Now, this is one way of solving this question. You can use any one of the 5 equations of motion or the definition of velocity and acceleration to solve this problem. Example question 17. A bullet is fired through a board 10 centimeter thick with a line of motion perpendicular to the face of the board. If the bullet enters with a speed of 400 meter per second and emerges with a speed of 200 meter per second, what is its acceleration as it passes through the board? So let's write down the given quantities. I have the thickness of the board, which we take as the distance the bullet travels through the board. And I write that as x minus x0 to be equal to 10 centimeter. Centimeter, we will convert it to meter by dividing this number by 100. And when you divide 10 by 100, you get 0.1 meter. Then the bullet enters. If it enters, that means this is my initial speed V0. I write V0 as 400 meter per second. And emerges means it is coming out with this speed. So this is my final speed V. which is 200 meter per second, I need to find the acceleration of the bullet. So since we have initial velocity, final velocity, and the displacement, again we are going to use the fifth equation of motion to calculate the acceleration. The fifth equation says that v final squared equals v initial squared plus 2a x minus x0. We rearrange the terms now. I will move v0 to the other side. So v squared minus v0 squared equals 2a x minus x0. Now divide by 2 and x minus x0 to leave a alone. And we get a equals v squared minus v0 squared divided by 2 x minus x0. Now substitute. Final velocity v is 200 square. Initial velocity is 400 square over 2 times the distance traveled, which is 0.1 meter. And when you solve this, you get your acceleration as negative 600,000 meter per second squared, which you can write as A equals negative 6.00 times 10 to the power 5 meter per second squared. Example question 18. A ball is dropped from the top of a building. It takes 8 seconds for the ball to reach the ground. How tall is the building? Neglect air resistance. Now, whenever the question says something is dropped or thrown or something is falling, that means this is an example of free fall motion. And when we are dealing with free fall motion, we know that in case of free fall, the acceleration of the object is equal to the acceleration due to gravity, which is a constant negative 9.81 meter per second squared. And now since the ball is dropped from the top of a building, the initial speed of the ball or the initial velocity of the ball will be 0 because the moment right before it was dropped, it was at rest. And the time it took for the ball to drop was 8 seconds. So my time t is 8 seconds. We need to find how tall is the building or what is the height through which the ball was falling. So we need to find what is y minus y0. Now to solve the problems in free fall, we use the same equations of motion, but in place of x, we replace x with y. Acceleration A will be replaced by g, which is negative 9.81. Everything else remains the same. Now, if I sketch my problem here, let's say this is the building, and you drop the ball from the top of the building. How tall is the building or what is the height of the building is the same as the distance through which the ball falls. So I can find the height of the building by just calculating the displacement of the ball or the distance through which it falls, which is y minus y0. If I want to find y minus y0 and I have the initial speed v0, the time t, and acceleration, I will use the first equation of motion, which says y equals y0 plus v0t plus half at squared. I need to find what is y minus y0, so I will move this to the other side. Y minus y0 equals v0t plus half at squared. Remember, whenever we are solving problem, distance or displacement is given by the expression x minus x0 or y minus y0 for free fall. So whenever they ask you to find the distance traveled or what is the height of something, this is the expression they are asking you to find. Now let us solve. Y minus y0 will be equal to initial velocity v0 is 0. And when you multiply anything with 0, you get the total expression as 0 plus half. Acceleration is g, which is negative 9.81. So I substitute that negative 9.81 times t squared. So I will take 8 squared. So you get y minus y0 to be equal to negative 313.9 meter. The negative sign here only indicates that the ball is moving in downward direction. So the height of the building is same as the distance through which the ball falls. So I can write the height h as 313.9 meter. Example question 19. A ball is dropped from a top of a 150-meter tall building. How long does it take for the ball to reach the ground? Neglect air resistance. So the question says the ball is dropped. Drop means again we are considering free fall motion. And if we are talking about free fall motion, that means the acceleration is equal to g, which is negative 9.81 meter per second squared. Now, this information is not given to you. You need to look at the keywords in the question to understand whether this is free fall motion, motion along y-axis, or motion with constant acceleration along the x-axis. So I have acceleration g equals negative 9.81 meter per second squared. It is falling from the top of a building. Now, when the ball is falling from the top of a building, its direction of motion is downward. So this distance that the ball covered, which is y minus y0, will also be negative because you're falling down. We need to find how long does it take for the ball to reach the ground. So I need to find the time t. Now when the ball was dropped, its initial velocity v0 would be 0. I have the initial velocity, I have acceleration, and I have the distance covered y minus y0. Again, I'm going to use the first equation of motion to calculate the time t. First equation of motion says that y equals y0 plus v0t plus half at squared. Now, this is the same equation of motion that we learned in section 2.7, which says x equals x0 plus v0t plus half at squared. Only in free fall motion, we replace x with y, and the acceleration I will take as the acceleration due to gravity, g. So let's move y0 to the other side. You get y minus y0 equals v0t plus half at squared. Now, I want to calculate what is the time t. So we can first substitute what is given to us. Y minus y0 is negative 150. Again, the negative sign here is because the ball is falling down. V0 is 0. Initial speed is 0. So when you multiply anything with 0, you get 0 plus half. Acceleration here is g, acceleration due to gravity. So negative 9.81. And I want to find what is t. So we get negative 150 equals, when you divide 9.81 with 2, you get 4.91 t squared. Then we can rearrange this and write t squared equals negative 150 over negative 4.91. I just divided with negative 4.91 on both sides. Then we take the square root on both sides to calculate t equals square root negative 150 over negative 4.91. And when you solve this, you get the value of t as 5.53 seconds. So this is the time the ball takes to fall from a 150-meter tall building.